You might have heard of a thing called the multiverse, this idea that there are multiple separate universes out there in space, apart from our own, that exist independently of everything that we can see. This idea is made possible in part by something called quantum tunneling. So let's try and explain how those two are connected. Let's imagine we're in a kitchen. We place a brown box on top of the refrigerator and a green box on top of the kitchen table. Now let's put a soccer ball in the brown box and wait a day. Then let's ask, is there a chance we'll see the soccer ball in the green box at the end of the day? We know that we won't because something would have to give the soccer ball extra energy to move it from the brown box to the green box. Now let's start over, but replace the soccer ball with an electron, a tiny negatively charged particle. We place the electron in the brown box and wait overnight. Then let's ask the same question. Is there a chance we'll see the electron in the green box at the end of the day? And it turns out the answer is, yeah, we might. Quantum mechanics tells us that tiny particles like the electron can tunnel through this energy barrier without any extra help. This process is known as quantum tunneling. In fact, without quantum tunneling, radioactive decay wouldn't happen. Quantum tunneling also leads to a release of energy when the electron tunnels during radioactive decay. So electrons aren't the only particles that can quantum tunnel. In fact, any particle that behaves according to the rules of quantum mechanics can also do this. We know that fractions of a second after the Big Bang, space itself was expanding incredibly fast. This is known as inflation and is part of the reason that our universe looks the way it does today. For inflation to happen, we need tons of energy. And in fact, it's thought that quantum tunneling of a particle called the inflaton is what gave us all of this energy and is the reason that inflation was possible. But there's nothing special about our spot in the universe. This means that just because quantum tunneling and inflation occurred right here in our pocket of space doesn't mean that it happened everywhere simultaneously, just like how radioactive material doesn't decay all at once. An inflaton could have quantum tunneled somewhere else at a different time, maybe is even doing so right now, beyond the reaches of things we can actually observe. In fact, there could be many different, widely separated pockets of space where an inflaton has quantum tunneled, leading to the expansion and evolution of another separate pocket of space where stars and galaxies, or maybe something completely different, have formed independently of our own. This is an idea that we call the multiverse.